Welcome you all for the lecture series on hazards in pipelining. In this lecture video, we are going to see about the one type of hazard, that is data hazard, and the methods to handle data hazard. Data hazard occurs when there is one instruction depends on another instruction. This is the situation which causes the data hazard, which may leads to the data inconsistency. When we are going with the pipelining, the processor execute multiple instructions at the same time. Sometimes one instruction depends on another instruction result. This leads to a data hazard. Data hazard occurs when an instruction requires a data, but that is not available at that particular time. We can hardly say the data hazard occurs when instruction J depends on instruction I. There are three different types of hazards, that is read after write hazard, write after read hazard, and write after write hazard. Whenever we are going with a write operation, we should ensure the data consistency. First, we will see about the read after write hazard. So it is also called as true dependency. Instruction reads the data before the write instruction of another instruction is completed. That is, we are reading a particular data that will be written by another instruction. Consider instruction 1 having the result in the R1, but instruction 2 reads the R1. So, once the result is updated in R1 by instruction 1, then only instruction 2 will read the R1. If it changes this order, this will lead to a data inconsistency. Here the R1, R2, sorry, instruction 2 reads the R1 before instruction 1 updates the results. So it leads to a read after write hazard. Next, write after read hazard. It is also called as anti-dependency. Instruction writes before another instruction reads the same data. This occurs mainly in the advanced pipelines. For example, instruction 1 uses the registers R1 and R2 to add and store the result in the R4. But instruction 2 adds the R3 and R5 and writes the result to the R1. Here, instruction 1 must read the register 1 value before instruction 2 changes it. If the order changes, it will lead to a data inconsistency because the instruction 1 needs the data that is not updated by instruction 2. So the order is important, but it is not happened, then it will lead to a data inconsistency which creates a write after read hazard. The third type is the write after write hazard. Here, the two instructions write the result to the same register. Here, which instruction write the instruction first and final result is the important one. This will occur in the parallel execution systems. Consider the instruction 1 and 2. Both the addition results will be updated to the register R1. But which instruction results to be in the end of the execution is the final one that should be maintained, or otherwise it will lead to a write after write hazard. To avoid the data hazards, we are following different methodologies. The first and easier one is the making pipelining stall. Pipeline pauses temporarily with the support of creating a bubbles in between. Consider in our example, we are having the 4 instructions. After the third instruction, there is a bubble is created in the pipeline. So it will delay the one cycle of execution. So the fourth instruction will wait and get the data and it will execute. It will make a delay in the pipeline stalls to wait to get an appropriate data, but it reduces the speed of the pipeline execution. Next method is data forwarding. It is a best method used in the used to avoid the data hazard. It is also called as bypassing. When the result is ready after a third ALU execution stage, but we can't get the results till the end of the fifth stage. So we are getting a data hazard and we are making a delays or creating bubbles to wait to get that results. To avoid this, the bypassing is created in the before fourth stage, after the third stage. So every stage in the pipeline have a buffers that will be represented as blue in this example. And the data forwarding unit, that is a simple hardware used to forward the data to the next unit. So the data is once ready, the data can be forwarded to the next instruction cycles. So we can avoid the delays in the pipeline stalls. It also improves the efficiency. The next method is instruction reordering. Here, the compiler rearranges the instructions and avoids the dependency conflicts and improves pipeline utilization. The next method is register renaming. This will avoid write after read hazard and write after write hazards, because the results of the registers cannot be written on the same register. The register can be renamed, so individual results can be saved. For this, it uses a different physical registers and improves the parallel execution. Advantages of handling the data hazard: it improves the processor throughput and reduces the execution delay and enhances the CPU performance. And thank you, one and all. Again, I will meet you in the next lecture series on another one type of data hazard and its handling methods. Thank you.